Next topic is purification of colloidal solution. That is nothing but reducing the amount of impurities which are present in the colloidal solution. So under purification of colloids we have three methods. One is dialysis and one more is electrodialysis and one more is a ultrafiltration. So dialysis, first process. So dialysis is nothing but it is a process of removing the dissolved substance from the colloidal solution by diffusion through a suitable membrane. So here the apparatus used for the dialysis is called as dialyzers, and for example parchment paper can be used or the animal membrane can be used. So here what is the principle used? The colloidal particles, they can be passed through the parchment paper, while the particles of the true solution can pass through the parchment paper. So if you use the parchment paper, the colloidal particle will not pass through the parchment paper, but the true solution particle can pass through the parchment paper. Like this one, filtration. Filtration, we take a filter paper, right? So the solid particle will remain on the filter paper and the liquid solution will be collected in a beaker. So same way here also the colloidal particle will not pass through the parchment paper, so they will remain on the parchment paper, where the particles of true solution will be passed through the parchment paper. So here what we do, we take a bag of suitable membrane containing a colloidal solution. So as you can see here, so here we take a bag of suitable membrane which contains a colloidal solution, and it will be suspended in a vessel through which fresh water is continuously passing. So from this direction we are passing the fresh water. So the molecules and the ions diffuse through the membrane into the water. So what happens here? The molecules or the ion which are present, they can be diffused through the membrane into the water, and the pure colloidal solution will be left behind. So here inside what we can see is a pure colloidal solution. So this is about the dialysis. Second one is electrodialysis. So electrodialysis is nothing but it is a process of removing the impurities from a colloidal solution by means of diffusion through a suitable membrane in a presence of electric field. So normal dialysis we use a membrane, but in the electrodialysis membrane will be used in the presence of a electric field. Ultrafiltration is nothing but in this process colloidal particles are separated from the solvent or the soluble impurities present in the colloidal solution by using a filter paper. That filter paper is a special filter paper which is known as ultra filter paper. So an ultra filter paper may be prepared by soaking the filter paper in a colloidal solution. So and it is hardened by dipping in formaldehyde and finally drying it. So ultra filter paper is nothing but it is a special kind of filter paper prepared by the dipping the filter paper in a colloidal solution. Normal filter paper in a colloidal solution, then it is hardened by dipping it in a formaldehyde, then you have to dry it. So ultrafiltration is a very slow process and you can speed up the process when the suction is applied. The colloidal particles, they are left on the ultrafilter paper, then it will be stirred with the fresh dispersion medium, that means a solvent, to get a pure colloidal solution. So initially colloidal particle ella ultrafilter paper alli collect agutte, then if you want to convert it into a solution you have to dissolve it using a suitable solvent. Then colloidal solution. So it is nothing but it's a 4% solution of nitrocellulose in a mixture of alcohol and ether, and the pore size of the filter paper is reduced by soaking it in a colloidal solution. So pore size ಅಂದರೆ ನಥಿಂಗ್ ಬಟ್ ಗ್ಯಾಪ್ ಫಿಲ್ಟರ್ ಪೇಪರಲ್ಲಿ ಜಾಸ್ತಿ ಇದ್ದರೆ ನಮಗೆ ಅದನ್ನು ರೆಡ್ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ಇದ್ದರೆ ವಿ ಕ್ಯಾನ್ ಡೂ ಇಟ್ ಬೈ soaking it in a colloidal solution. Next, properties of the colloidal solution. So first one is colligative property. So colligative property like osmotic pressure, lowering in vapor pressure, or depression in the freezing point, or elevation in the boiling point, it depends on only the number of particles in the solution. So very important. What is colligative property? So colligative properties are the properties which depends only on the number of particles present in the solution. So colligative property values for colloidal solutions are less than the true solution for same concentration, because colloidal solution contain particles which are formed by the aggregation of many molecules. Hence, for a given mass of salt, the number of particles decreases. So next one is Tyndall effect or the optical property. Optical is nothing but light. So Tyndall is nothing but so the property related to the light. So the salt is taken in a parchment paper bag. So and it is suspended in a pure water taken in a tank, and we have to apply a electric field by dipping 2 electrodes in a pure water present in the bulk water. So what we have to do? The salt will be taken in a parchment paper bag and it will be suspended in a pure water, and electric field is applied by dipping the electrodes in a pure water present in the water tank. What this will do, it will speed up the migration of ions out of the parchment paper towards the oppositely charged electrodes. So here, as you can see, we can take the colloidal solution or the salt in a parchment paper, and we can take 2 electrode. One is anode, that is nothing but positively charged towards the oppositely charged electrode. So what is the definition? Tyndall effect is nothing but it is a scattering of light in all the direction by the colloidal particle. So that is called as Tyndall effect. So this scattering makes the path of light visible to our eyes. So that is about the Tyndall effect. So Tyndall effect is nothing but it is related to the light. So optics. So Tyndall effect is nothing but the scattering of light by the colloidal particles. So what is the condition to observe the Tyndall effect? So the diameter of the dispersed particles is not much smaller than the wavelength of the light used. So the colloidal particle what we take, their diameter should match with the wavelength of the light used. And the refractive indices of the dispersed phase and the dispersion medium should differ greatly in magnitude. So you already know what is refractive indices. So there must be a difference between the refractive indices of dispersed phase and the dispersion medium. So this effect was first observed by Faraday and it is later studied by the scientist Tyndall. So milk is a colloid that contains globules of fat and protein. So when a beam of light is directed at the glass of milk, the light gets scattered. So this is a great example for the Tyndall effect. And when torch is switched on a foggy environment, the path of light becomes visible, right? So this you might have observed. In this scenario, water droplets in the fog are responsible for the scattering of light. And the projection of beam in cinema projector is visible due to the scattering of light by the dust particles. So, all these are the example for the Tyndall effect. So, Tyndall effect is also used to distinguish between the true solution and the colloids. Next one is about the color. So, the color of the colloidal solution, it depends on the wavelength of the light scattered by the dispersed particle. So, based on the wavelength of the light scattered, the color of the colloidal particle also varies. And it also depends on the size and the nature of the colloidal particle. So, direction of the observer also, it depends on the direction in which a person is observing the color. So, mixture of milk and water appears blue when viewed from the scattered light, and it appears red when viewed from the transmitted light. So, it varies on the position in which you are observing the color. Next one is Brownian movement. That is nothing but the continuous zigzag motion like this. As you can see in the diagram, the zigzag motion of the colloidal particle is called as Brownian movement. So, it was first observed by the Robert Brown, and the Brownian movement is due to the unbalanced bombardment of the colloidal particle by the molecules of the dispersion medium. So, here all the places you can see colloidal particles, right. So, what this colloidal particle will do? They will bombard with each other and then they will change the direction. So, this zigzag movement, that is called as Brownian movement. So, it depends on the nature of the colloid as well as the size of the colloidal particle and the viscosity of the solid. So, viscosity is nothing but by which speed they can move. So, all these factors, it affects the Brownian movement. So, smaller the size, lesser will be the viscosity, then faster the movements. So, size small idre particles enagutte fast agi move agutte. So, size small idre viscosity kuda less irutte, so movement fast irutte. So, faster will be the movement. Next, what is the importance of the Brownian movement? So, Brownian movement opposes the force of gravity and does not allow the colloidal particle to settle down. So, Brownian movement is nothing but the zigzag movement of the colloidal particle or the random movement of the colloidal particle, right. So, what they will do? They will not allow the particles to settle down. So, it gives the stirring effect and thus it is responsible for the stability of salt. Next one, electrical properties. So, charge on the colloids. So, colloidal particle always carry either positive charge or the negative charge. The presence of equal or the similar charges on the colloidal particle is largely responsible in providing the stability to the colloidal solution, because there will be a repulsive force between the charged particles having a same charge, prevent them from coming close to each other and aggregating when they come close to each other. So, equal charge, as we know, always they will repel from each other. So, positively charged sol and negatively charged sol. Examples, we can write many examples. Hydrated metal oxides, methylene blue, hemoglobin, all these are the example for the positively charged salts. Whereas metals, copper, silver like metals or metallic sulfides or salts of starch, gum, all these are example for the negatively charged salt. Next, what is the reason for the charge on the colloidal particle? So, it is mainly due to two reasons. One is electron capture by Sol particle during the electrodispersion in Bredik's arc method. So, a colloidal particle can capture the electron, due to which they will get a charge, or preferential adsorption of ions from the solution. So as I told you, when we add ions containing common ion, what happens? They will preferentially absorb the ion. So that is the second one. Formulation of electric double layer. So that is the third reason for the presence of charge on the colloidal particle. Next, explanation about the preferential adsorption of ions. So when two or more ions are present in the dispersion medium, preferential adsorption of ion, which is common to the colloidal particle, usually takes place. So if we add excess of hot water to a positively charged sol of hydrated ferric oxide, it is formed due to the adsorption of Fe3 plus ion. So when FeCl3 is added to sodium hydroxide, a negatively charged sol is obtained with the adsorption of OH minus ion. So when we add AgNO3 solution to the Ki, that what happens? There will be a precipitation of AgI, right? Because Ag is plus, NO3 is minus, K is plus, I is minus. So Ag will react with I to give AgI precipitate, which what will do? It will absorb the iodide ions from the dispersion medium, which is nothing but potassium iodide, and thus negatively charged colloidal solutions will be formed. However, when Ki is added to the solution of AgNO3, positively charged sol results due to the adsorption of Ag plus ions from the dispersion medium. So, Ki and AgNO3, when you mix, again you will get Agi only, but here Ag and Ag is common now. So, what happens? Agi will adsorb Ag plus ion from the medium and you will get a positively charged sol. So, this is about the charge. So, next, these are the same what I explained now, it is written in terms of equation or written in the form of formulas. So, the charge on the colloidal particle attracts the counter ion from the medium, obviously, right. So, opposite ions attract each other. So, the charge on the colloidal particles, they attract the counter ions from the medium. So, combination of two layers of opposite charge around the colloidal particle is known as Helmholtz electric double layer. So, if this is a colloidal solution, if there is a positive charge on this colloidal solution, then again if there is a negative charge, so there will be a formation of double layer, right, electrical double layer, which is called as Helmholtz electrical double layer. So, the potential difference between these two fixed layer, that is the first layer and the second layer, between the fixed layer and the diffused layer of opposite charge, it is called as electrokinetic potential or the zeta potential. So, this is about the charge on the colloid. Then electrophoresis. Electrophoresis is nothing but the movement of colloidal solution towards the oppositely charged electrode. Okay, so positively charged colloids, always they will move towards the negative anode, negative electrode, that is nothing but cathode. Same way, negatively charged colloids, they will move towards the positive electrode, which is nothing but anode. So, same way, the movement of colloidal particle towards the oppositely charged electrode are called as electrophoresis. So, electrophoresis is used mainly to determine the charge of the colloidal solution. So, the positively charged particles will move towards the cathode, while negatively charged particles will move towards the anode. So, electroosmosis, nothing but electrophoresis, that is movement of particles is prevented by some suitable mean. It is observed that dispersion medium begins to move in a electric field. So, this phenomena is called as electroosmosis. So, if you prevent the movement of particle by doing something, by doing suitable actions, what happens? Dispersion medium starts to begin in an electric field. So, this phenomena is known as electroosmosis. Next one is coagulation or the precipitation or the flocculation. So, the process of setting of colloidal particle is called as coagulation or the precipitation. So, precipitation ಅಂದರೆ ಇಂಥ ನಾರ್ಮಲ್ ಆಗಿ particles settle ಆಗುತ್ತೆ, right? So, here the colloidal particle, if they settle down, then it is called as coagulation. So, coagulation of leophobic salt can be carried out by the following methods. One is boiling. So, when the salt is boiled, the adsorbed layer is distributed due to the increased collision with the molecules of the dispersion medium. So, this reduces the charge. So, ultimately what happens, they will settle down as the precipitate. So, when you boil, adsorbed layer will be disturbed. ಸೊ ಎಂತಾಗುತ್ತೆ, ಅದು ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಕೊಲಿಷನ್ ಆಗೋದು ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಕೊಲಿಷನ್ ಆಗೋದು ಜಾಸ್ತಿ ಆದರೆ ಎಂತಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ರೆಡ್ಯೂಸಸ್ ದ ಚಾರ್ಜ್ ಆನ್ ದ ಪಾರ್ಟಿಕಲ್ which ultimately leads to the settling down of to form a precipitate. Then by mixing to oppositely charged salt. So when we mix two colloidal solution of opposite charge, they should be mixed in a proper proportion so that charge on one colloidal particle will be neutralized by the charge on the another colloidal particles, leading to the precipitation. This is called as mutual coagulation. So, giving and taking. For example, mixing of hydrated ferric hydroxide, which is a positively charged salt, and arsenic sulfide, which is a negatively charged salt. So, the charge on one another will be neutralized by opposite charges. So, precipitation will take place. Then by mixing to oppositely charged salt. So, when a salt is boiled, the absorbed layer will get disturbed. So, there will be increase in the collision of particle in the dispersion medium. So, what it will do? It will reduces the charge on the particle. So, ultimately what happens? They will settle down to form a precipitate. Next one is electrophoresis. So, during electrophoresis, what happens? The colloidal particle will migrate towards the oppositely charged electrode. So, as I told you, positively charged electrodes, they will migrate towards the cathode, and negatively charged particle, they will be migrated towards the anode. So, this is about the migration. Or by adding a electrolyte. So, when we add excess of electrolyte, the colloidal particles get precipitated. For example, when we add excess of sodium chloride to arsenic sulfide salt, the Na plus which is present in the sodium chloride, they will neutralize the negative charge on the colloidal particle. So, arsenic sulfide settles as the yellow precipitate. Then we have one important rule, that is Hardy-Skulls rule. So, greater the valency of the flocculating ion added, greater will be the adsorption. So, charge, now flocculating ion what we add, if it has greater charge, then the precipitation also greater. So, ion which causes the precipitation of a particular salt is called as active ion or the flocculating ion. So, in the coagulation of negative salt, the power will be in the following order, that is aluminium 3 plus, so Al3 plus, so its charge is more, right. So, precipitate also it will form more, then barium, then sodium. In the coagulation of positive salt, the fluctuating power is in the order. So, again like the positive charge, negative charges also have fluctuating order. So, it will be in the order FeCN6 4 minus, then FO4 3 minus, then SO4 2 minus and Cl minus. So, this is about the precipitation. Next, coagulating values or the flocculating values or the precipitating value. So this is nothing but the minimum concentration of electrolytes required to cause the precipitation in 2 hours. It is called as coagulating ion. So coagulating power is proportional to the coagulation value. So it is reciprocal of the coagulation value. The smaller the value of coagulating ion, higher will be its coagulating value. So this is about the coagulation. Then coagulation of a lyophilic salt. So solubility of lyophilic salt is mainly due to two factors. One is the charge on the colloidal particle and one more is a solvation of the colloidal particle. So if we remove these two properties, then even the lyophilic salt will get coagulated. So that can be done when solvent such as alcohol or acetone is added to the hydrophilic salt, or it is also possible by the dehydration of the dispersed phase. Addition of salt, small amount of electrolyte also causes the coagulation. Next, protection of colloids. So the stability of lyophilic salts is become they are extensively solvated. The lyophilic colloids form a layer around the lyophobic salt and protect them from the electrolysis. So lyophobic means water hating, right? So this lyophilic colloids, what they will do, they will form a layer around the lyophobic salt and then they will protect it from the electrolytes. So this lyophilic salts are called as protective salt. So gelatin is used to protect gold used in the medium, or even gum arabic is used to protect Indian ink. Even milk is stabilized by the milk protein called casein. Thank you.